Hello everyone, welcome to Applied IoT Lecture number 6. I hope everyone is doing well. Last time in this lecture we stopped at market perspective of IoT. We talked about market size and growth. Um, we talked about what the market right now, and we talked about how the future looks like, and we talked about there is still room, how there's still room for the IoT market to grow, where the opportunities are and how far that we have to go. So we talked about how much opportunity that IoT have as a marketplace. Industrial adoption, we talked about that as well, right? How wide range of industries are now using IoT systems, right? We talked about several set of IoT systems that are there. They are in different industries, different domains, and we overall the market size and the market adaptation. We talked about how when this market adaptation takes place, when these industries adapt and this market size grows, and for there are some services that we have to maintain when IoT is introduced, like introducing IT to go into a paperless environment, right? When we introduced a cloud-based storage system, cloud-based application system to certain industry, right? There is a certain amount of maintenance that is needed to be done to there should be a set of technicians, engineers who should take care of that IT infrastructure. Similarly, in this growing marketplace, there after industry adoption is completed, right, there is the market for maintenance of that IoT infrastructure. So we also talked about that point as well. Before continuing into the rest of the topics and talking about market perspectives, we will first look at what we have gone through so far in applied IoT, and try to get an understanding or to get a refreshment of what we have gone through. We went through introduction of IoT. We try to understand what is IoT, right? What is the nature of IoT or the definition of IoT. In this case, it was the Internet of Things described. So Internet of Things or IoT describes the network of physical objects or things that are embedded sensors, actuators, processing ability, software and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. This is a basic definition of IoT. Most recently, when I was going through some subject matter, I came across another interesting way of defining IoT. This person describes it as trying to make physical objects into computers. Or making physical objects into electronic devices is another way of, well, it could be another way of understanding IoT. Then we then went on to look at IoT devices, examples of IoT devices. We talked about cameras, temperature monitoring and control, lights, motion sensors, so on and so forth. Then we talked about some industrial applications such as robotic arms, smart hospital beds, smart locks. Then we have health monitoring, autonomous driving, monitoring devices. We went through all these examples. Then we looked at examples of how these devices are applied in certain scenarios. We talked about how weather monitoring IoT devices are applied in temperature control, and we talked about these devices are being applied in different domains of hiking, fishing, in aviation, smart cities, smart buildings. We talked about how IoT devices can be used in conjunction to each other to automate it for one particular purpose. In this case, it is fire prevention and handling fires that occurs in buildings, right? How the alarm system would go, how the sprinkler system would go, so on and so forth. Then we looked at how each device could be applied in different industries and domains. With each IoT device with a set of properties can be applied in different domains, right? We can mix and match them as well. So we talked about that. So at this point we have a basic then we till that point we got a basic understanding of what is IoT, right? What are IoT devices and what are their functions. We would be now able to identify what is a IoT device. Then we stepped into introduction to applied IoT. Applied IoT refers to the practical application of Internet of Things or IoT technologies and solutions in real world scenarios across various industries and domains. It involves using IoT devices, connectivity, data analytics and cloud platforms to solve specific challenges. Or here these are the most important part of the sentence. We apply IoT to solve specific challenges, or in other words, to solve problems, improve processes. So that means existing solutions, improve them, make them efficient, make them more accurate, make them automate them so that it will be much better, quicker and accurate. Enhanced decision making. So enhanced decision making means that because we have in IoT, because we have access to so much data which is being produced by different sensors, that we can use that large amount of data, right, to take out information, to make decisions and create value. Of course, if you are applying a IoT solution, if you are a certain domain industry and you are trying to use a IoT device, end result should be to create value to the company or to the industry or to the service that you are providing, so on and so forth. That in the financial world, in the world we live in the capitalistic world we live in, that would be the main end result. The end result would be to create value. So I will go through this again. In applied IoT, we apply IoT. We learn how to apply and why we apply IoT, and that is mainly to solve specific challenges, improve processes, enhance decision making and create value. After that, we looked at different domains or different industries is around the world that use IoT as a value adding solution. Consumer, home goods, healthcare, retail, industrial, transportation, security, logistic, storage, warehouses, agriculture, power grids. So these are few of the topics. We can say they are the main topics, but there are, so here we don't even talk about industries such as military industry. So there are many industries out there that uses IoT to add value, improve their processes, enhance decision making in their industries and domains, as well as to specifically resolve challenges. that they face. Then we went into understanding characteristics of IoT when we provide IoT solution, when we apply a IoT solution, when we put on the table a IoT solution, there will be a set of properties which will be there, and number one would be the connectivity, the networking, the hardware or the perception layer, data analytics, automation controls, scalability, security, privacy, real-time communication, heterogeneity, edge computing. So these will be the properties which will, or the characteristics that would be there in an IoT system. And as you can see, if you have connectivity, if you have data analytics, that means you have cloud computing, automation control, if you have scalability, if you have real-time security and privacy, that means all these things demand another market just to maintain those systems. So there are, as we talked about markets before in here, right, market size and growth, we also have to understand that every application which is already there for IoT has a market for maintaining and scalability. Scalability is a part of IoT. So if they want to increase their capacity, increase the number of items, that is something that is there in the marketplace. So so we know that the marketplace is there to there's more space to expand. Introduction to M2M, machine to machine. Machine to machine refers to communication between two or more devices, typically without human intervention. It involves exchange of data, commands, or information between machines, enabling them to collaborate, interact, and perform tasks autonomously. Basically, automation of production lines and practices we are talking about. Machine to machine is a concept that is there in industrial level and before IoT, but today the line between machine to machine and IoT has been blurred. We can say quite safely that it is been blurred, but there are some differences between IoT and machine to machine. In overall, if we are to design a IoT solution for industrial scale process, right, like industrial automation, if you take, okay, we use IoT devices, we talked about how these robotic arms works, these pumps works, and so on and so forth. So that means to give a IoT application for these legacy systems would be giving a machine to machine solution as well. So that is where the line would get blurred, right? So we can say overall in IoT, machine to machine is a part of this whole function. We talked about smart grid, transportation, fleet management, healthcare. We talked about all these things and how IoT works, how M2M works in these, and we talked about smart cities as well. In length, we talked about these things. Then we talked about machine to machine and in Internet of Things. What are the differences? We talked about the scope. We talked about data sharing, connectivity, scalability, so on and so forth, data analytics and ecosystems. Mostly by understanding the difference of these between Internet of IoT and machine to machine, it would be the legacy systems or and the integration between legacy systems and new methodologies in the technological world. So IoT is a much newer concept compared to machine, but today if we are going to give a machine to machine solution, or which means we are going to automate some process. The end result would be a IoT result. Same scenario, I also introduced operational technologies as an additional thing, and because it is going to be the same scenario plus. Today I came across another wording that is there also in the workspace, IIoT, or Industrial Internet of Things, which is also OT, M2M, and IoT. These are M2M, OT, IIoT. All these are subcategories. We can say all these are subcategories of IoT according to today's technology. This is one of the points that is important. If you go through some information, or if you go through some books or something, that you will find there are differences between in M2M and IoT, but with today's technology, right, there are no separately working individually working technology out there, right? For example, you have data mining, you have big data, right? If you have IoT devices producing large amount of data sets, you would, to process those and things like that, you will have data mining algorithms, you will have big data processing methodologies out there. You will use cloud computing if you are going to use if you are going to store large amounts of data which has been produced by IoT devices, right? So cloud computing cannot be a separate thing from IoT. We can, if there's big data and those to process those, then we can use AI technology which is there. So though these are key technologies, AI, cloud computing, big data, whatever the technology that we use, these are separate technologies with today's level of developed technology development. IoT is not a separate subject from cloud computing, right? So the line has been blurred. You cannot define a specific line saying this M2M and IoT, this is the exact difference, because if we are to build a IoT device for an industry today, or if we are to build a M2M system for an industry today, it would be similar to an IoT device, right? So that is what I wanted to tell on that particular slide. And then when we went into market perspective of IoT, so we first talked about, again, market size and growth. We talked about how much growth can be expected, as well as how much opportunity is out there, right? We talked about markets which have already adapted IoT, but we recognize that there are more marketplaces, industries, domain which have not adapted IoT, and going forward, that there is a large gap of for the market to grow, as well as when the IoT market grows, similarly service providing for infrastructure management would also grow. So those two IoT, so building IoT devices, as well as maintaining the networks, the security of those IoT devices, software, maintaining the cloud for those IoT devices, those subcategories of maintaining IoT system would also grow alongside. So industry adaptation, we talked about it, and we talked about how still there is a long way to go in industrial adaptation. Some industries such as car manufacturing industries, or we would have any industry that would have streamlined the process. For example, chip manufacturing, in circuit board manufacturing companies which have mostly automated the process and streamlined the process have adapted IoT. We talked about mining, how they can how we talked about autonomous driving, delivery, logistical purposes, how these industries have adapted these technologies. But then again, we talked about how there is space for industry adaptation, because if you see the difference between developed and developing economies, is the adaptation of IoT is completely different. So we talked about one of the examples that was there for there in measuring the amount of fertilizer, or the amount of nitrogen, oxygen, or the amount of fertilizers needed in the soil for plants, and by that controlling the amount of fertilizers that is being used. And we talked about how it was very successful for India and how that impacted as a byproduct for the entire market and production of food, so on and so forth. So we were looking at those. So we know that there is a lot of industry adaptation to be done, and industry adaptation has been successfully carried out in certain industries. So from that point onwards, we can go to the next topic, which is connectivity and devices. Connectivity and devices. So as we can see that when coming into Internet of Things, connectivity is a main part of IoT, or in a main characteristic of IoT. We know that the connectivity between the sensors and the processing units, the connectivity between each IoT device, and to make it IoT, connectivity to the internet itself, whether we have to send data or receive data, connectivity is one of the most important things. So here, the growth of IoT is closely linked to advancements in connectivity technologies. The development of 5G networks, low-powered wide area networks, LPWANs, and other wireless technologies enables seamless connectivity for a vast number of devices. Moreover, the cost of sensors, processors, and other IoT components has been decreasing, making it more feasible for organizations to deploy IoT solutions at scale. So if you think about IoT and in IoT network, right? If we are to scan, let's say, a 500-kilometer pipeline or an electricity distribution line, right? There will be multiple number of IoT devices should be there along the way if we want real time in data from those devices. Let's say at least we need 100 to 200 devices, and all these devices needed to be connected to the internet to relay the data to the internet, or for some kind of a network to relay the data to the central control room to monitor that, let's say, pipelines which carry oil or gas, right? So in that perspective, if you are, if the uh, uh, a marketplace is created for the network side of IoT, if we are going to connect every physical thing to the internet, it would become a IoT generally. So that means that network capacity have to grow alongside with the number of devices that we are going to use. The example that is being highlighted here is the 5G networks. So this is, as you know, that when introducing 5G technology, if you go through articles, one of the main points that they try to communicate is that self-driven vehicles should be connected to each other, and that connection would share large amounts of data, and large number of vehicles have to have the capacity to be connected. 4G does not have the full capacity to have that many devices connected at any given point. But 5G, a property of 5G is the number of devices that can be handled by a single transmitter would be greater than 4G, thus giving the ability to add more devices or maintain connectivity of more devices in the environment, meaning that more devices can be used without any interruption of connectivity. In IoT, the other part of this networking would be a low power wide area networking. There are many types of low power wide area network just dedicated to IoT itself, because uh, as we discussed before, if you take networking of IoT devices only in an IoT system, there could be hundreds of IoT devices that are communicating to each other. That particular part would, if we are to communicate through 5G networks, or if we are to communicate through the internet or the existing Wi-Fi network, that would be unnecessary use of bandwidth, because if you have around 500 devices sending out data and retrieving data at all times, and in real time as well, it is better to have a dedicated networking system between them rather than using resources that is there to connect to the internet itself. So as IoT devices are small devices which consume small amounts of electricity, and sometimes if the device is powered by batteries, low power consumption is a priority. In that particular sense, we can use low powered wide area networks, right? So the market, when we talk about the marketplace, if you're coming into networking, there are network devices and network service providers, right? So if you take network devices and service providers, or the network protocols, for example, we talked about, we have Bluetooth, Wi-Fi, Bluetooth low energy, LoRaWAN, NB-ITO, IoT, NB-IoT, Sigfox and Zigbee. So these protocols are there with their own unique hardware, which can be integrated into a IoT device, and network can be maintained. As long as those special networking protocols are running, there will be a demand for providing services to maintain that network. Then of course uh, we cannot stay without our normal existing network infrastructure, your core devices, your access points, gateways, and so on and so forth. If you want to use 4G or 5G, there are some hardware components such as your 4G, 5G antennas, your cellular service providers, and the SIMs that you use for connectivity, so on and so forth, right? So each environment, if you take Wi-Fi connectivity or your fiber optic connectivity to the internet itself, so all these networking connectivities protocols, with networking the other section that comes in is security. All these services and devices have to be integrated when creating a IoT system, and when integrated, uh, these should be maintained. That means a service maintaining the network would be provided as a service. If you are to establish such a network system, ATM machines or weather monitoring systems, right? There are service providers in Sri Lanka, let's say for example Mobitel or Dialog. These service providers still have the opportunity to expand their network to facilitate these IoT devices, right? And others, so, and not only these main network providers, you can build your you can have your own companies to, if you to build your own IoT system and the network in between those devices in the IoT system itself, and you will be the service provider. So the market perspective of connectivity is really interesting when coming into IoT, because the network demand is high. The amount of devices that are there in the workspace or which is there in the industry is very high. If you take actuators, if you take a water pumping station, there would be numerous amounts of pumps which have to be controlled. Numerous amounts of pressure sensors would be there in each part of the pumping station to check the pressure of each pipe. There would be uh, there would be relays to control the the motors. There would be instruments to measure the amount of water in tanks. There will be valves that is needed to be automatically opened and closed. So these set of actuators and set of sensors would be there in a single pumping station. And in the pumping station, the control room would have maybe one or two computers. And if you think about the environment of that pumping station, the control units, which in this case could be desktop PCs or laptops, would have maybe one or two connectivities, right? That could easily be managed by either Ethernet cables or by Wi-Fi. But the amount of IoT devices that are there would reach around 100, depending on the scale of that pumping station. So if you take the market perspective for connectivity, networking, and that particular section, the demand from IoT is much more greater than the demand for IT infrastructure. Right? For if you take IT infrastructure, the IT infrastructure, networking is supported for laptop PCs, which will be each there for individual, and there would be maybe networking between the printer and the laptops and the data centers. That's it. But when you take IoT devices, a 50-story building would have uh, would have at least over 250 um, smoke alarms. And if these are to be networked, as we talked about in our first few lectures, think about the capacity that is needed to be handled by the network itself. Think about the expansion of network. So the marketplace is much the connectivity marketplace, the connectivity devices that are needed, and the networking devices and the networking providers, or the service providing. These two section of the network market is much bigger in IoT than IT. So as the IoT market grows, the demand for building network infrastructure to maintain that capacity, and uh, for the existing infrastructure to be maintained as a service would be there on the IoT marketplace. We talked about in market size and growth and industry adaptation that there is more space for growth. If there is more space for IoT to grow, that means there is more space for IoT networking to grow as well. In that sense, um in that sense, the network side of things, right? The network side of things has the potential to grow with that market size when the IoT market size increases. Then we talked about sensor. Other devices would include sensors, processors, and components. So we talked about this in market size and growth, right? In industrial adaptation. So more the IoT devices are being built, more the IoT devices are being sold in the market, more they are being used, the amount of sensors and processors which are being manufactured will go up. And also, if you take 10 years back, when IoT 10 or 15 years back, when IoT came into uh, our our world, or as a prominent technology, right? Telling that okay, IoT will be the future. The prices and the capability of processors at that time is significantly different from the prices and the capability of processing at this time. So currently we are able to buy processing power, sensors, networking equipment with much more reliability, much more processing power, much more capabilities for a lesser price than 15 years ago. So that is also an advantage when creating IoT devices, because we have the ability to make more effective IoT devices, more capable IoT devices, and we have the ability to introduce these IoT devices to the IoT market with a competitive price, because the costs have gone down. Because when let's see now, if you take the processing abilities, if you take Snapdragon 8th generation or Intel Core i7, so Mac M2, these chips are the highest level, and those processing powers are expensive. But for IoT, we need something around mid-range and lower. Today, the mid-range and lower, if you take Intel i3 processors, or even lower processing units, those are more than enough to power IoT devices, right? Therefore, but they have extremely good processing power as well. So the price of them are also cheaper. The processing power is much higher than before, right? So we have been able to get good sensors and processing power and also actuators for a decreasing price. So that is also an advantage. That is uh, not only for the processing power in connectivity, or if you say core devices and APs and so on and so forth, it is better for the entire IoT, to build a IoT system. So more capable IoT systems can be built with less price. Next we have data analytics. So this is the portion when after connecting to the internet, right? After connecting to the internet, where the data is stored and analyzed. IoT generates massive amount of data from interconnected devices. This data holds valuable insights that can drive business improvements, enable predictive maintenance, optimize operations, and enhance decision making. The integration of IoT with data analytics platforms, machine learning, and artificial intelligence enables organizations to drive meaningful insights from the collected data. So, uh, the first part of it is that it says it creates a massive number of data points, right? Yes, that is true. Let's say if you are going again, we talked about many examples before of so we about electricity grids, pumping stations. For this, let's take a hospital. If you have a hospital, there are different large number of patients with different needs would come to the hospital. Some would need 24-hour measuring of their pressure. Some would need to check their blood sugar levels. Some would need to take check their ECG, or their heart rate monitoring. Some would need constant dosage of medication or saline. So um, these supply of oxygen, maintain supply of oxygen, uh, cleanliness in these hospitals, especially in the ICU, should be maintained, and the air should be filtered. Those things should be measured. um, Doctors and nurses should have the ability to monitor any patient, especially patients in ICU, in real time. These, and if you talk to a person on the medical side, or in your medical department, or doctors, you will understand that the requirements in the medical industry is a pretty large amount. And if more automation can be introduced, which is a very hard thing to do for medical side because of the sensitivity that is required, but if can, more lives can be saved, and doctors will have quick response times and good results. So in in a place like that, the amount of data that is being generated in real time for monitoring, and the amount of data that is being collected in the database itself. For example, if let's say there are tools to monitor the temperature of patients, and if a large number of patients comes in with fever, the hospital can so that particular set of data, so different patients would be coming to different wards or meeting different doctors, but all of them would have the similar symptoms, or IoT devices will have the ability to collect that, okay, their blood oxygen levels are low or they have fever, some couple of symptoms like that. That data could be fed into a secure central database, and that when that data is processed, that with the past data, let's say compared to the past month or compared to the past year, this time the amount of patients who are having fever is significantly high, so that we can say there will be a pandemic or an epidemic taking place, and the hospital then can manage accordingly. How? The hospital can then bring in more medication and stockpile more medicine which is needed to tackle the fever, right? If oxygen is low because of this sickness, then they can bring in more stockpiles of oxygen. They can inform authorities to the health ministry, and through health ministry programs can be carried out to see what is spreading, what are the factors which are helping to spread this pandemic, so they can prevent it. So all that information, right, all that decision making was done because of the data which was presented by those IoT devices. That data comparison and data analytics was done in so from a massive number of patients that were coming into the hospital, because fever patients will be there all year round to a hospital. We have to check with past data to see if there's a spike or abnormality in the amount of patients that they have. This is just one example, right? Think of the amount of sicknesses that are out there. We are talking about thousands, and symptoms from each and everyone would differ. But if all those devices which are used to measure health properties of human beings are connected to a database where analytics on that data can be carried out, patterns will emerge so that the hospital or the medical industry can take measures to avoid pandemics, right? So this is what we are talking about when coming into valuable insight to drive business improvement. In this case, the business would be medical industry. Enable productivity enable productive maintenance. We will talk about it in another example, right? Optimize operations. Yes, in the healthcare sector we talk about how they can be prepared for this situation and measures can be taken out to save lives, right? Enhance decision making. Of course, those decisions to bring in more medicine, stockpile more medicine, bring in more oxygen tanks was taken. That decision was taken because of the data which was collected in the hospital. So if you go to another industry, enable predictive maintenance is that sensors can show that if deterioration of instruments takes place or machinery would take place, right? Instruments, if if that instrument, let's say okay, let's say our irrigation network, right? And in that irrigation network, there will be sensors to measure the amount of water which has been carried through irrigation canals, or the speed of water, right? From that they can predict if there are let's say changes which happens to the speed of water, maybe due to rain. The amount of water and the speed of water flowing increases due to massive amounts of rain. This would damage the canal system. If the canal system is scanned through barometric or ground penetrating radar or IoT device, very complicated IoT devices like that, they will be able to create pictures of the interior of that structure and show the weak points, so that maintenance crew can go and quickly patch it up before it becomes a big issue. If you take another example, would be your engine light, engine warning light in your vehicle. There will be an array of sensors that would be measuring the temperature of the engine, or the functions of the engine, the heat produced from the engine, so on and so forth. If those one of those sensors detect a difference or abnormality in those metrics, that data will be used to indicate that there's a problem in the engine itself. So so that before the engine itself breaks down, we can predict that there is going to be an issue and do maintenance to prevent that issue from happening, right? Doing maintenance is less costly than replacing the engine itself after breaking down, right? So that would be an example for predictive maintenance. Integration of IoT with data analytic platforms, right? Machine learning and artificial intelligence. As I told you before, these things, machine learning, big data, artificial intelligence, now go hand in hand, and they process large amounts of data points. And a platform or a system that would produce a large amount of data points would be IoT systems. So going into the future, a combination of so in artificial intelligence, machine learning, and data analytics or big data, big data, or data mining platforms, or any of those defining technologies. If there is a hardware component at the end of it, either taking measurements or carrying out commands, it would be a IoT device. It would basically be a IoT device. Now, what is the market perspective of this? We know that all major companies, when coming into cloud platforms, so all this data should be monitored in cloud platforms. When coming into cloud platforms, AWS, Google, Azure from Microsoft, all provide cloud capabilities, tools in their cloud platforms to manage IoT devices, to store data which is being produced from IoT devices, to create networking or virtual networking inside the cloud platform itself to the IoT devices, to process large amount of IoT data, to carry out real-time processing and real-time outputs of taking in and outputs of data from IoT devices, and many more. So that capability, that functionality as a service is given by cloud platforms. And that means that as a service provider, as an infrastructure service provider, similar to networking, When you build a IoT system or an IoT network, or you use IoT data, you can give that information as a product. For example, a company that measures whether in a country will have IoT devices located around the country itself, and they can make predictions on weather systems in the country itself. That data can be sold as a product. What would be the weather like in the future? Or maintaining that particular IoT system or systems for a company, right? So infrastructure management of IoT, including the databases to store data, including the data centers, including the cloud platforms, including the networking, including the hardware, can be given as a service. So that means there is a market for that. Of course, in the first point and the second point, we talked about that there's a long way to go and long way to expand. That means more data will be created, more methods of analyzing that data will be created. So that means when coming into data analytics, this similar to the networking, data analytics would as a service would grow. So, if you take the market size and the growth, right, and if you take the industrial adaptation um, for IoT, along with connectivity and data analytics, the market perspective of IoT seems extremely positive. There is more room for growth. There is um, there's as long as there will be automation in industrial platforms, there will be IoT present at all times. And also that we can take the market perspective in two categories. One, as a service provider for the infrastructure, and the other would be a device and software manufacturer. As there all the predictions in the world that is made, that IoT is going to the use of IoT is going to increase, the market space is going to increase, the market perspective would be that for manufacturers of hardware and software, it is going to be positive. And also for in the software side of IoT, right, after you sold a software, there will be no new enhancements, new properties which will be added as updates. So there will be a continuous market going on. And when coming into hardware, of course, like smartphones, like cars, we will have new versions at least one or two time, at least once, twice a year, even the smallest products we have. So updating hardware equipment, updating of or replacing broken hardware in an existing system would be there. So that means there is a market space, a continuous market space for IoT product manufacturing. And as always, for infrastructure management, when coming into IoT, right, we talked about networking and data analytics in the cloud platform. So infrastructure management in traditional IT sense, and the infrastructure management of the IoT devices itself. would be there, and it would, as long as the systems are being used, it would be continuous. If there are to have changes in the market in a negative manner, it would be a globally defining moment, economical collapse affecting in multiple number of industries, and the whole world's economy going bad, because IoT has its branches all over in every industry, in agriculture, in medicine, in right, in the military sector, or in other industries such as mining, so on and so forth. IoT can be used. So the whole so there should be a catastrophic incident that have to take the whole industry down. But if you are a company that is providing services or manufacturing IoT devices for a particular industry, let's say smart homes, we know that sometimes the uh, the market for land or property market would fall down. There are possible, we hear this news. 2008 we saw it on in United States. Quite recently there were some incidents happening in China, and big markets can be affected through this. And if you are only concentrating on smart home markets, then your IoT company or your IoT business, either service providing or manufacturing, would be affected. If you are diverse in if you have a diverse portfolio in different domains, industries, markets, because IoT has a wide range, the impact can be softened and it would be less. Overall, if this progression of technology keeps on going, if the trend of automation keeps on going, the market perspective of IoT would always be positive and will have room for growth. From these 4 points, let's go to several points which are uh, would be secondary in nature, but there is also a market for this. There's already, so if you take the next point, it would be security and privacy. As IoT systems grows, ensuring the security and privacy of data becomes crucial. The interconnected nature of IoT exposes devices and networks to potential cybersecurity threats. Thus, robust security measures, including device authentication, encryption, and secure data transmission, are essential to protect IoT ecosystems and maintain user trust. Yes, similar to the protocols that we are running today in our IT infrastructure for smartphones, for our laptops, for our desktops, for our servers, in our networking, so on and so forth, right? We use sometimes we use two-layer authentication systems. Encryption is necessary even communicating, right, secure transmission of data. Those protocols, we those standards, that is ISO there are ISO standards for this as well. So those standards for security and privacy should be transferred to IoT devices as well. Yes, it consumes a lot of it consumes some amount of processing power. Yes, it consumes a little bit more from networking, a little bit more from processing, a little bit more from energy if you are running it through batteries. But this is a very necessary perspective. Think of the last example we talked about. We talked about a system in a IoT system in a hospital. That data of an individual is private and personal data, and that data should be protected in most countries around the world, including EU, especially the data of a patient, the medical records of a human being should be protected at all times. So when you have a IoT device monitoring a person's health, that data which has been produced and propagated into servers through networks, that data which has been stored inside data centers should be protected from hackers, and should have very little access to only the people, only the individual, and, and permitted people such as doctors and nurses should have the ability to access that data. That is something very important. That is one industry. But when coming into different industries, the financial impact is very critical if we are not to protect our data. And because IoT systems are such with presides with a big network, this will give vulnerable points for hackers to hack into the system. Unlike laptops and smartphones in a office environment which has been issued by the office, where there will be controlled two-stage authentication, encryption, and there will be fire like internal firewalls and with external firewalls inside IoT system, maybe where uh, things like um, Bluetooth or low powered networking such as Sigfox would be being used, right? Or Z-Wave is used. In that, if we don't have the appropriate protocols running on the IoT devices, it would be a vulnerability point. If we are to send data from device to device without encrypting, depending on the validity of the data, that would be a vulnerability point. So security and privacy, right? It's there on IT infrastructure management side, right? That will be propagated into IoT as well, right? We talked about different names that are being used: M2M, IIoT, OT side, right? So all these and IT would have it would be a part of IT. Security would be a part of IT infrastructure, security and privacy. Therefore, um, so if you take the market perspective, we all know that security has a special market perspective, especially for service providers. There will be regulations that must be followed. As I told you, in the medical industry is one of the best examples. Therefore, if we are to digitalize everything, there should be a service provider who will be handling the security and privacy of it. So as long as a digital infrastructure is there, either IoT, if you either you call it M2M, IoT, IIoT, OOT technologies, or any other name, similar to IT infrastructure, this infrastructure should have a security layer as well. Standards and interoperability. So this is another fact which we can say more than having the manufacturing and service as a business. This is a point, having standards throughout every product will help this industry to grow. The development of the industry standards and interoperability frameworks is essential for the widespread adoption of IoT. Various organization consortia are working to establish common protocols, data formatting, and interfaces to ensure seamless integration and interoperability among different IoT devices and platforms. So, one of the things when we talked about networking, when we talked about security standards, right, we talked about a set of protocols which is already being used. Using HTTP, HTTP communication, using TCP protocols, using data formats that are being understood by databases and functions like cloud storage, and which can be processed. So as you can understand, the set of data which is being produced by sensors would be mostly in analog form, and that analog data should be turned into either digital format, or if possible it would be uh, turned into turned into a value through digital format or in the analog format itself, right? So when that particular sensor data is given a value, so that value could be stored, that raw data can be taken and it will be transformed into a set of data that could be understood for the human being itself, which is in the format of a value, and that number, that particular set of bits should be then networked and transferred to stored, so on and so forth, according to the protocols which are already existing. So that's why these standards are so much important, right? Let's if let's talk about products that are available in the marketplace. Most of the products in the marketplace for smart homes, you will see that they have the ability to integrate with um, with products which are being given through Amazon, right? So that means that the main point of that is, if you are a third party which is selling your, let's say, smart washing machine or your smart lights, they have the ability to connect to Amazon control products. In this case it would be Alexa. When the verbal command is given to Alexa, Alexa would be able to communicate with the smart lights, or the smart washing machine or the smart music player, so on and so forth. That communication with the third party product and Amazon and product, right? That communication is carried out because there are standards between standards used for communication between these two devices. So this is what we are mean by standards and interoperability: the ability to integrate into a system. If we are to make um, if if the market to grow or the industry to adapt, it would be easier if we have several types of control systems, and from that we find one control system which, okay, let's say for smart homes we use Alexa, but if you are going to use smart lighting systems to an entire building, it would be a control room. It would be a so the lighting system would be controlled either through sound, by clapping the lights will turn off to turn on, or by gathering data from the internet to see what, or seeing the light compared to the outside, the intensity of the light, checking that part out and automatically turning on. So for carrying out any of this function, right? If there is a common open source code out there for the product, it is easier for engineers to buy the products and integrate them together in one particular system when designing an IoT system. So interoperability and standards comes through there. If you are building your product to a particular standard, you will have the ability to integrate with other IoT devices which are built on the same standards. So, like security and privacy, having standards and interoperability is very important when making a IoT device. If you take the market perspective, especially when coming into commercial functions, rather than like commercial use for industries, smart grids, smart water distribution systems, smart cities, big projects. When we talk about that, if we are going to use IoT in such big projects, big mining projects, construction of, let's say, harbors, if you take the port city, if we are to make that a smart city, so it would be a big project. For those big projects, having the market perspective for having security and standards or interoperability and maintaining privacy of data from the is it's a must have in IoT products. So the market would favor if your IoT product not only have the normal like the normal IoT properties such as having sensors and connectivity to the internet, the market would favor very much if you have the security and privacy of data and standards and interoperability built into your system. It is very easily adaptable. If it is easily adaptable to the existing IoT system, plus it has good security features, that would have a better marketplace, that would be sold much more in a market than an IoT devices with issues in integration, with issues concerning privacy and security. If the market perspective for a IoT product which if somebody finds out there's a security issue and there is a backdoor or to enter into the systems, or attacks could be carried out, hackers can easily tap into this IoT device, the market will reject that particular device very quickly, especially the commercial, not more than smart homes or individual use, especially the market where large quantities of IoT is sold, the commercial market. So if you take the market perspective, these two properties, point number 5 and point number 6, should be there in a product to compete in the market, the growing market itself. And the market perspective for startups and innovation. The IoT market has seen significant involvement from startups and technology companies, driving innovation in terms of new products, services, and business models. Startups are leveraging IoT to disrupt traditional industries and create new market opportunities. The venture capital investment in IoT startup has been substantial, indicating the investor confidence and interest in this space. So, if you are to have a startup, right? Normally, a startup is that you will find a problem, then you will find a solution. If you have to have a IoT startup, that means you will be addressing a problem from using IoT device or using a IoT system. So it depending on what kind of domain you are trying to go into, what kind of industry you are trying to help, one kind of decision making that you are going to help, right? Your um, your startup or invention or your innovative idea would be supported in the market. um, Normally in in this world, the startup industry now mostly works with software, right? If you have seen startups which have been successful in Sri Lanka as well, it is more towards creating software side of things. So that means there's a large space there for hardware as well, right? So IoT is all about hardware, all about electronics, all about solving problems through hardware solutions. It, venture capital will always follow a good idea, right? We have Hatch in Sri Lanka, and there are some different organizations which pump money into this, and also universities would also support projects, right? So the main and if you have the ability to reach beyond Sri Lanka, venture capital investments would be there for IoT products. By now in the market, there are thousands of products that are being that is in use, especially for smart homes. But the opportunity is there. The opportunity is there for industrial applications, because sometimes the IoT devices for industrial use should be specifically made to that industry. It should be tailor made. In that sense, there will be a good opportunity. I think we talked about an example which was created in our nanotechnology center, where Sri Lankan inventor was able to produce a machine that has the sensors, the capability, and to measure the amount of nutrients in the soil itself. By that, the ability to uh, measure the um, amount of urea or amount of fertilizer that is needed to be used, thus saving money for the farmer, uh, only putting the necessary amount of um, fertilizer and not wasting on extra. So the but that technology was, I think, sold to India, because there was no successful investment in Sri Lanka. But that is not a story to get demoralized, because the invention was so good that there were other countries, there were other marketplaces that would buy, that would invest on that opportunity. In that case, if you have a good IoT product, there will be a definitely a market to it. So again, in the marketplace, is there a place for IoT products? Yes, there is, right? And what about startups and innovation in the marketplace for IoT? There's plenty of room. If somebody creates a new sensor to detect something, the possibilities of creating IoT products from that sensor would be great. So for startups and innovation, there's always a possibility. We can measure moisture, pressure, light, motion, but then again, those sensors have limitations. If we can build a better sensor with less limitations, with which creates less error when creating data, so on and so forth, that would be also an innovation. And that would be, if you start up a company building a better sensor than the one in the market, of course there will be investors ready to invest on you. So, and again, when you are creating a startup, you should have that product up to standards and would have security and privacy on top of these things. Therefore, that the market adaptation will be there, right? There will be people who will believe in the product itself. So for startups and innovation, again, the marketplace, like every other marketplace, is positive. um, we talked about we have room for growth, especially when you take South Asian countries, African countries, Latin American countries, right? So we are talking about more than billions of um, dollars of economy. We are talking about billions of people. When coming into GDP, it's on trillions. Those economies are still yet to adapt IoT systems for automation. So, yes, startups have a place in IoT. Regulatory environment. As IoT become more uh, pervasive, regulatory frameworks and policies are involving to address concerns related to data privacy, security, and ethical considerations. For this, again, the best example would be EU policies, right? There are the I think the most strongest policies would be there on EU, and when you go from country to country, from government to government, these regulations differ. Governments and regulatory bodies are actively working on developing guidelines and regulatory regulations to measure responsible IoT development and protect customer rights. Yes. So, the main point, similar to AI, similar to data collection or on social media and other platforms, right? IoT has that danger. We talked about security and privacy. We talked about security and privacy of patients in hospitals using IoT devices and that data collection and how it's going to be. So basically, the regulatory environment, or if you take bureaucracy itself, governments are lagging behind. To they Because the technology evolved so fast, it take some time for the governments to catch up with it. So still, new rules and regulations are being rolled out. The market perspective of it is, if you are to build a IoT device and it has the security and privacy protocols there as standard, The hardware component of the IoT system, which is the sensors and actuators, would be fine, because if there will be any regulatory implications or new regulations coming through, it will mostly affect the data which is being collected and an analytics. So where the data is stored and where the data is processed and what is the data being collected. So in that perspective, only what is the data being collected will affect IoT devices, because sensors would collect data, right? Uh, Other than that, a direct action to stop IoT device production in a specific way, or let's say a government declare, okay, if you have a particular sensor with these properties, you cannot use that sensor due to safety reasons and so on and so forth. An example would be when drones or quadcopters. Drones came into existence. The adaptation was very fast, right? There were cameras today for agriculture. We use them for scanning whole areas. We can use them. We can use them with lidars. We can use them ground penetrating radars for research, for, and you can see in the war that is taking place that drones are being used. So governments were quick to ban those usage of drones in sensitive areas, where like say the parliament, presidential buildings, security places such as military camps, near airports where it could disrupt flights, so on and so forth. Therefore, so in so small, the market perspective, depending on the regulation which is being rolled out, there will be a positive or a negative, if take on, depending on the positive or the negative take of the IoT device, right? The market perspective will change negatively and positively accordingly. For example, if all drone usage for civilians were banned, this is just an example, that market will get a hit, right? That IoT market, the sensor market for cameras, the actuator market for the motors, so on and so forth, will be getting a hit. In a similar way, if you say the government decides to digitalize and make a smart grid for the whole country, bring the grid up to date, the impact on the market would be positive. There will be devices which will be taken to monitor specific to monitor electricity consumption. There will be devices which are taken to monitor the production of electricity, to detect any faults in the transmission lines. If thermal power or hydropower, there will be sensors there to detect those facilities, so on and so forth. So the users will be high. So depending on the regulations which have been rolled out by governments, the marketplace would change up and down. Even innovation and startups would have an opportunity if the government regulation says that, oh, we are going to invest more on technology, more on IoT. If they concentrate more towards that side, it will affect the startup market as well, market perspective as well. So from all these, right, we know that if standards and security privacy is met, right, we know that it would affect positively towards your IoT products. For startups, we know, depending on the environment and depending on the economic situation, that it will affect, but it is also positively. Still, the indicators show that the startup market is positive. We know that market size and growth is still, there is room for growth and to increase the market size, so it's positive. Industry adaptation, we know it, there's going to be industry adaptation. We talked about all these topics in different domains and industries. So we know that there is still yet a long way to go. So growth is there. Perspective is simply positive. Connectivity and devices and data analytics, this is more towards the infrastructure side, where the IT infrastructure can be utilized for Internet of Things. And for if there is market growth, then it will be positive for the service providers. So these 4 points are positive. If these two points are fulfilled in your product, the market perspective is positive. But the only thing that could change, apart from a global economic crash or a pandemic situation creating a global havoc on the marketplace, would be regulatory environment, where governments or institutions would pass negative legislation for IoT usage. But then again, if there were positive legislation, the outcome would be also positive. The market perspective would be positive. Additionally to all these, right now I have few topics over here, which is AI, artificial intelligence, renewable energy, virtual and augmented reality, blockchain technology. In the middle we have Internet of Things. So these are the buzzwords today in the marketplace and today in everywhere else, right? If you are going to, if you are going to see, okay, what will be the technologies which will be defined in the next 10 years, it would be artificial intelligence, it would be renewable energy. We know that because of climate change and everything, renewable energy is going to get the marketplace is going to get increased. Artificial intelligence, we saw how chat GPT and the aftermath of that. So we know that there's going to be a progression in that side very heavily in the next coming 10 years. Blockchain technology has matured for some amount of time, but we are yet to see practical applications on blockchain side, right? And there is a marketplace between Internet of Things and blockchain, because these two doesn't interact much as the other subjects in this virtual reality and augmented reality. We talked about the gaming platform. There are beyond gaming, um, of course virtual reality and augmented reality is used beyond gaming platforms, right? And to run a virtual reality or augmented reality platform, let's say for training astronauts, training fighter pilots, training commercial pilots, so on, and training people on nuclear power plants, so on and so forth, right? These sensitive things, all the hardware equipment would be a part of IoT. In renewable energy, IoT will be used heavily. Let's say if to measure the wind, to measure the sunlight, so on and so forth. Artificial intelligence, of course, use a large amount of data to function correctly. So a place where a large amount of data is created, an ecosystem which creates a lot of data, is Internet of Things. So Internet of Things can actually support artificial intelligence, renewable energy, virtual and augmented reality. So mainly on that environment, looking at the future, because everything is getting integrated, right? We know that artificial intelligence is going to grow as a product. We know that renewable energy is, legislation is also passed, regulatory environment is also positive for renewable energy. We know that's moving forward. Virtual reality and augmented reality, we see that companies like Apple have taken significant steps to make innovative solutions out of virtual reality. So we know that IoT is a part of these Like these are all connected to each other, and IoT is a part of these topics, right? As I told you, between blockchain and Internet of Things, there might be a small gap, but innovation will fill this gap as well. So, end of the day, if these technologies are to take on the future, and part of these technologies, IoT will be going forward in hand, the overall market perspective would be positive. It is simply that growth is there, it is still there, right? These are emerging technologies, though IoT, like so we can say IoT, blockchain, and renewable energy has come a long way from their beginnings, right? Artificial intelligence, virtual reality, they are still taking a start, but these three technologies have come some significant distance, but there is more to go. And from all these technologies, Internet of Things is the more Internet of Things and renewable energy are two of the topics which are more reliable and stable, right? We know that they will have a definite future. We don't know what will happen to artificial intelligence will with government regulations and people having positive and negative conversations about it. Virtual reality needs more refining, more processing power, more investment, and it will not be a technology which will be in day to day use like your smartphone. It will take some time to come into the smartphone level. Blockchain technology is also having in the regulatory problems such as similar to artificial intelligence. But renewable energy and Internet of Things is very much here to stay. Those are safe. It is, we can safely say that in the next coming 10 years, Internet of Things will definitely be there as a marketplace. So the market perspective overall positive, and if you take the next 10 years, next 20 years, IoT will be a part of the technological industry. Okay, now we can come into value chain of IoT. So we were talking about the market perspective in different angles, right? How the market is and where the market can grow and what are there. So we talked about IoT as a emerging technology, though it has been some time, we still have the perspective to grow. So overall market perspective was positive on this. So we talked about two things, right? On the talking about market perspective, one was the manufacturing IoT as a product. It could be the software, it could be the hardware. Then we talked about services for maintaining the IoT infrastructure. So now we IoT as a business, we see that there are two sides for it, right? On two markets, right? Which is there, which is there and which will grow on IoT industry. So where does these markets come to when we are talking about value chains, right? Before looking into IoT value chains and what are the examples of these value chains out there, what are the market opportunities which are out there in IoT, or which are the sections of markets, parts of markets, right? Different types of markets in IoT. Right, first we will look at take a small introduction to value chain. A value chain is a series of consecutive steps that go into creation of a finished product, from its initial design to its uh, arrival at a customer's door, right? The chain identifies each step in a process at which value is added, including the sourcing, manufacturing, and marketing stages of its product, right? So here, when you say, okay, there is a finished product, the product could be physical, like a hardware device. The product could be non-physical, like a software, or even a service, right? So if we are to manage the infrastructure itself, it would be a service providing rather than giving a product. So a value chain, I just got this from Harvard Business School, so online platform. They had this a simplified, we can say a simplified version of a value chain. So so the inputs will come through here, right? There are primary activities. These are the primary activities when creating a physical product. Secondary activities, which is there to maintain the manufacturing line or the company, the operations of the company itself. Merging all together will help to create products. Those products will have value, right? That is what we try to understand from value chains. So introduction to value chain, we can see a value chain is a series of consecutive steps that go into creation of a finished product. Simple as that. From its initial design to its arrival at the customer's doorstep. That means logistical part is also involved. So it's all about creating a product and selling it to a customer or delivering it to a customer. The product would have value, and all the steps that are necessary, it could be primary, it could be secondary, whatever the steps that are necessary to build that product will be a part of a value chain, right? So there are different perspectives that we can take of on IoT and IoT value chains. First, let's look at the basic understanding of this value chain. So we talked, these are the points that we have to talk about when coming into producing a product, right? The consecutive steps that needed to be taken. So primary steps would be inbound logistics, receiving raw materials, right? Warehouse, inventory management, so on and so forth. Think of producing a car. You will need raw materials to build the engine. You will need raw materials to sheets of metals to build the car itself, right? You have to press them and you have to make. So in operations, a process involved in turning raw materials and components into finished products. So that means when you have let's say a sheet of metal, it would be pressed into the shape of the car with large presses, and components will be added in, right? So example, in a complex value chain, right, all of them will be not raw materials. So for example, we will have wiring to the car. The wiring to the car would be coming from a secondary company. That company's value chain will be exactly in this structure as well, it will take the copper and everything as raw material, copper and rubber, but the wiring would be coming as from a second, the not as raw material to the car manufacturing company, but you get the idea. So in the operations, you put them together, and there will be outbound logistics, so distribution including packaging and storing, marketings and sales, of course, promotion and advertising, after sales services. Of course, there will be, especially for cars, we say one, or if you take a phone or a laptop, you say 1 year warranty. That would be the after sales services. Inbound logistics, operations, outbound logistics, marketing, in sales, and after sales services. These five components, one or all these components together, are the primary activities which are there to produce a product. If you think about it, let's say a software. In software, right, the raw material would be human resource, where software engineers will be carrying out the function, right? Operations will be lot it would be the whole software development life cycle, where the product will be born, right? Outbound logistics would be sending as an update or sending as a new product the software. Marketing and sales, after sales services. After sales services would be, let's say you introduce a new antivirus software, you're sending it, you have to then maintain that antivirus software by sending updates. So after margin in, you will have value created, right? Secondary activities would be infrastructure, company overhead management, including in financing and planning, human resource management, right, recruitment, hiring, training, development, technology development would be research and development, including in product design, marketing, research. So it is easier to have the, and let's go through this first, then procurement for taking raw materials in, and so on and so forth. For this basic structure is very good for creating raw material, creating physical, we can say it is very good for creating physical products. But if you have software, or if you are ESA or SaaS, like software as a service, infrastructure as a service, so on and so forth, the structure would differ a little bit. But overall, all these things together, primary and secondary activities together in a large corporation, would create the final product, right? You would need the infrastructure. But there are different ways that we can look into this, right? Now, before going into IoT infrastructure, let's look at the basic and where IoT would be coming in. If we talked about IoT, so this is good. This structure here, this diagram is here good for physical products. So in IoT, the device itself, the IoT device itself, is a physical product. So that means there will be inbound logistics, your sensors, your actuators, your wiring, your network components, right? Your device itself, the cover, maybe in operations, you will be putting them all together. Then you will have outbound logistics, right? You will distribute it. If you go to amazon.com, you will find a lot of IoT devices. That's a part of distribution. Marketing, sales, and after sales, of course, a company will be there. Procurement of raw materials would be there, and human resource management would be there for taking in engineers, and software developers, network developers, so on and so forth, would be there. Infrastructure and technology development would be a part will be together. For engineers will have 3D printers, they will have computers, 3D modeling computers, they will have test environments, they will for software and for hardware. There will be uh, R&D departments which will carry out, which will build prototypes, so on and so forth. That infrastructure will be there in itself. So needed laptops, software processing powers, and data centers will be provided as infrastructure. All those together will create a company which will give out a product which is a IoT device. It or different types of IoT devices which will contribute to IoT system. That's how value, that would be the part of value creation, right? So but now we have to talk about deeply about creating or having a value chain, and in which parts does IoT creates value. Because now we talked about of creating a company which creates IoT devices, how it goes through. But using IoT for value chain, for technological development, let's say a place where let's say we say manufacturing of vehicles, or a hospital, or a medical providing medical services as a product, or providing bank services as a product, or manufacturing of or mining, right? Manufacturing of raw material as a product in mining. In these IoT devices can be used in the technological development layer and infrastructure layer. To build the infrastructure, or to build the infrastructure of that, let's say a mining company, to build to do the technological development, right? To carry out its function operations as operations of drilling, in processing raw materials, so on and so forth, IoT infrastructure is used. Similar to IT infrastructure, IoT infrastructure is used. In that case, the maintaining the infrastructure as a service or is also a thing that so this infrastructure should be maintained, and maintaining that infrastructure is something that creates value. So most of the time what businesses do is they concentrate on their main product. If it is a hospital, their product would be medical services. If it is a car manufacturing place, the product would be the car. If it is a mining company, or if it is a logging company or something like that, the product, the mining company, the product would be the raw materials. It would be coal, it would be gems, it would be minerals, things like that, iron ore or something like that. If it is a timber company, it would be cutting trees, processing trees, is into different products. The infrastructure that is used, if they are to automate most of the function, the infrastructure they use, the IoT devices, we talked about many examples before, so I'm not going to repeat that part again. So that to think that each of those, to create each of those products, there is a IT and a OT, or in this case IoT infrastructure. So maintaining that infrastructure would go to, will be given to another company. So what will happen is, if you take ITSM or ITIL process, the agreement between two companies will be creating value for each other. So the car manufacturing company will be creating value because the IoT infrastructure is functioning properly, so they can release their product. The service providing company will create value because their product is maintaining the IoT infrastructure, and if they are doing that, they will get paid. That means that the value will be creation. So uh, both sides benefit from infrastructure support. So these are the main two types that we have to talk about when coming into value chains, right? We have M2M value chains. We have to touch a little bit about that. Then we have to IoT value chains, and what are the, in here we have to talk about what are the value chains that will can be created, and what are the opportunities that are there, right? To create value, create like a company creating sensors have the ability to create a product on the whole IoT value chain, right? This is a value chain of creating a product. Here we can talk about what are the products out there in an entire IoT value chain or entire IoT system, right? Then we can talk about other companies, and the similar, we can expand on these topics as well. For today we will stop from here, and from next point onwards we will talk about IoT M2M value chains. We'll talk about a little bit, then we will go to IoT value chains and understand what kind of market opportunities are there in IoT. So thank you everyone, see you in the next lecture.